Greetings everyone, welcome to our video presentation. In this video, we will present to you experiment 4, which covers Hooke's law. Our group consists of 4 members, which are Isaac, Janessa, Vanessa, and me, Hadzin. We will be discussing the objective and findings of this experiment. The objective of our experiment today, as you can see on the slide, is straightforward, yet fundamental to physics. Our aim in this experiment is to verify the accuracy of Hooke's law. As we can see in this slide, it is about the list of apparatus necessary for our experiment. The required items are a helical steel spring and a little sand to set up the main structure. We will apply various loads using a set of slotted weights that weigh 50 grams and a hanger that weighs 10 grams. Ensuring precision with a laboratory balance. Further items for specific procedural steps include a needle and clay, and the essential measuring instrument, the ruler, will be used to record the spring extension.
The first step in our experiment is measuring the mass of the hanger and spring. As shown in the picture, a sartorius balance was used to determine the mass M of the spring and the hanger. The second procedure is the scale was adjusted so that the pointer on the hanger is near the upper end of the scale when the hanger is unloaded. Its position was recorded as X initials and a table on a data sheet was prepared. Next, the hanger was loaded by 10 grams of weight. The load kept increased by suitable increment to obtain 5 data points before the lower end of the scale is reached. All data was recorded accurately throughout this process to ensure the validity of the result to subsequent analysis. Lastly, the process was repeated by loading the same loads as in procedure 3. Average for each load was recorded.
Here are the results for our Hooke's law experiment. We have recorded the mass added in kilograms, the calculated force in newtons, and the resulting spring extension in meters. The spring itself has a mass of 0.01576 kg, and the hanger used in the experiment has a mass of 0.01 kg. As expected from Hooke's law, you can observe a clear proportional relationship as the force applied increased. The extension of the spring also increased linearly. Now, moving on to the practical application of Hooke's law. Here is a problem many of you might recognize from the lab. The question asks us to plot a graph of the force causing the extension against the extension, x, and then determine the gradient of the graph. So, from the graph, we take 2 points that is quite close to the straight line and find the gradient by using the equation y2 minus y1 over x2 minus x1. Therefore, we got 3.182 nanometers. So, in this slide, how we find the force applied with the stretching of spring of 0.05 is to see where the x equals to 0.05, touch the straight line and get the y point, which is 0.175 Newton. For this question, how we find the energy stored is we use EP equals to half kx squared, where k is 3.182 and x is 0.05. And from this calculation, we got the value of energy stored is 3.9775 times 10 to the power of negative 3 joules.
When conducting this experiment, there are multiple potential sources of error. In this slide, the question that is asked is describe any error that may have occurred during this experiment. First, we have the parallax error. This happens when we read the measurement scale from an angle rather than directly at eye level. Second, inaccurate mass measurement. If the masses are not properly calibrated or if we misread the values, our force calculation will be incorrect. Third, improper alignment. The spring must be hung vertically for the measured extension to be accurate. Fourth, a worn-out spring is a significant issue. If a spring has been used repeatedly, it may no longer obey Hooke's law. Finally, oscillation and swinging of the spring during measurement can cause unstable and fluctuation readings. From the question in this slide, we can describe that the relation between extension of a spring is directly proportional to the force applied. For the discussion, we find that the experiment successfully investigated and verified Hooke's law, confirming a direct proportionality between the applied force and the extensions of a helical spring within its elastic limit. A graph of force versus extensions showed a linear relationship, and the gradient of this straight line represents the spring constant K, where a larger slope indicates a stiffer spring. In conclusion, our experiment successfully verified Hooke's law for the tested helical spring within its elastic limit. Our result demonstrated the predicted linear relationship between the applied force and the resulting extensions of the spring. Consistent with the theoretical principle F equals to Kx, we determined the spring constant, a measure of the spring stiffness, from the gradient of the force extension graph, which validated our hypothesis. That's all from us for experiment 4. Thank you!